Welcome back, everybody. We are up to lesson 7 of unit 6. So let's take a look at our examples here. The center of a Ferris wheel is 40 feet off the ground. Okay. And the radius of the Ferris wheel is 30 feet. So what they're saying is that this right here is 40 feet. Okay. And then if I change the color, the radius is 30 feet. Okay. So no matter where I draw the radius is 30 feet, which means this little part right here is going to be 10 feet in order to get the center 40 feet off the ground. Calculate how high off the ground point P is as the Ferris wheel rotates counterclockwise starting from 0 radians. Remember, 0 radians is right here. 0 radians and 0 degrees are right here. So to give us an idea of what we're talking about here, what I'm going to do is I'm actually going to convert all of these radian measures to degrees. So we're going to start with pi over 12. And if you go back to your lesson notes from lesson 1, remember all the notes from the first half of this unit were with lesson 1. One of the things here is you have a quick radian degree converter here. So that's just a quick way you can get an idea of where they are. So let's go ahead and do that. So this is what happens. So we want to convert to input pi, type pi. So we want to convert pi over 12 from radians to degrees. So pi over 12 is approximately 15 degrees. So on the diagram, and I'm going to use a different color for this, on the diagram, 15 degrees is going to be approximately right here. Remember, directly up from center is 90 degrees, or pi over 2 radians. Directly left of center is 180 degrees, or pi radians. And then directly down from center, so that would be over there, would be 270 degrees, or 3 pi over 2 radians. Okay? So 15 degrees is going to be somewhere in this first quadrant right here. So we want to find how high this point in green is off the ground. So how high is it off the ground? So in other words, we have to figure out the y values, the y value of that point, because the y value will tell me the vertical height. So how high off the ground is the y value? Okay. And why is that significant? Well, if we go back to our lesson notes, okay, if we go back to our lesson notes, our y value is the radius times the sine of the angle. So if I do the radius times the sine of the angle, that will give me the y value of this point. The problem is it will only give me the height. It will only give me the height right here. Okay, the y value will only give you the height down to the positive x-axis. So if we assume that this is the origin, if I do radius times sine of the angle, it's only going to give me the height down to here, which means in order to get the actual height, I have to add 40 to it. Okay, remember the center is 40 feet off the ground. So when I find the y value of the point, it's going to give me the height down to the center, and then from the center to the ground is going to be 40 feet. So for each of these, I'm going to take the radius times the sine of the angle, and then I have to add 40 feet to it in order to get the true height, not just the height down to the center of the Ferris wheel. So remember, the radius in this case was 30 feet. So I am going to, in Desmos, I'm going to do 30 times sine of pi over 12 radians, and then I'm going to add 40 to it. Okay? And whatever that is, that will tell me the height at pi over 12 radians. So let's load up Desmos. Okay, remember, we want to go to the wrench, double check that it's in radian measure. So we're going to do 30 times sine of pi over 12. Whoops. And then I'm going to add 40 to it. So we're going to call that 47.8 feet. So 47.8 feet is what we'll round it to. So the only thing that's going to change for each of these is the angle. So B, I'm going to do 30 times sine of pi over 2 plus 40. And then I'm going to do 30 times sine of 5 pi over 6 plus 40. So the only thing I have to change is the angle. So the second angle for part B is pi over 2. So the answer there is going to be 70 feet. Okay. Will be 70 feet. All right. And then for the next one, we're going to change the angle to 5 pi over 6. So 5 pi over 6. So that's approximately 55 feet. Okay. And then we're going to then change it to 5 pi over 3 radians. Okay. So that's approximately 14 feet. Okay. So that's number one. Number two, as you go around on the Ferris wheel, at which positions would you be 60 feet off the ground? Explain your reasoning. So we know that at 15 degrees, we're just under 48 feet off the ground. We know that at pi over 2, which is directly up from center, we know that this is, 70 feet. Okay. So this was about 48 feet. This is 70 feet. And we know here, directly right of center and directly left of center, we know that that is 40 feet off the ground. So it's going to hit 60 feet. It's going to hit 60 feet somewhere in here and somewhere in here. And it's just a matter of figuring out what that angle is, okay? So what we're going to do is we're actually going to create an equation. I'm going to do this right here, okay? So it's going to be, let's see, we're going to do 30 times sine of A, since we don't know what the angle is, plus 40. 30 times sine A plus 40 equals 60. Okay? 30 times sine. So we're going to solve this equation for sine and then get our angles. So I'll start by minusing 40 from both sides. Okay? So 30 times sine of A equals 20. Then I'll divide both sides by 30. Okay, so I'm going to have sine of A equals 2/3. 20 over 30 is the same as 2/3. So to figure out the angle, remember I have to do the inverse sine of 2/3. So that's sine to the power of -1 of 2/3. So inverse sine means the angle whose sine is 2/3. So to do that, let's go back to Desmos. And if I want to do the inverse sine, if I go to functions and I go to trig, notice the inverse sine is here. So if I clear this, I can do inverse sine of 2/3, okay? And if I want to see what that is in degrees, okay, it's going to be approximately, let's see, approximately 42 degrees. And in radians, that would be 0.7297, so 0.73 radians. So that's going to be that's going to be this first point right here. So that's going to be 0.7297 radians. Okay, or what did we say? It was about 48 degrees. If we change it to degrees, 42 degrees, excuse me. So it's 0.7297 radians or 42 degrees. Okay, so this angle right here, okay, is 42 degrees. So to figure out what this angle is right here, notice it should be symmetrical around 90 degrees. So 40, if we assume that it's 42 degrees, okay, if we assume it's 42 degrees, okay, so 90 minus 42 is 48. So that means there's 48 degrees between here and 90. So that means I need to go 48 degrees on the other side of 90 to get this second point right here. So that means I need to take 90 and I need to add 48. Okay, and I get 138 degrees. Okay, so basically to sum up what I did here, when I did the inverse sine of 2/3, I got 42 degrees. Okay, so 42 degrees is, there's 42 degrees, there's 48 degrees between 42 and 90, because 90 minus 42 is 48. So now I have to go 48 degrees on the other side of 90, and I got 138 degrees. So 138 degrees, okay? And now I can go ahead and I can convert that to radians if I want it in radians. So I can go back to this calculator, and I can convert 138 degrees to radians, and I get 23 pi over 30. 23 pi over 30 as a decimal. 23 pi over 30. We're going to say that's 2.4 radians. So, in summary, as you go around on the Ferris wheel, which positions would you be 60 feet off the ground? It'll be at 42 degrees, and 138 degrees. And in radians, that would be 0.7297 radians and 2.4 radians. So that would depend on whether we were giving the answers in degrees or radians. I would accept either one, since it didn't specify whether they wanted the positions in degrees or radians. Okay, that is it for this lesson.